Alright, hello once again. This is Jeff Scott of Rankin Technical College. As part of the Rankin Technical College AWD, or Application and Website Development Program, and in particular the AWD1100 C# Programming Fundamentals class, I've been doing a series of video presentations based on the PowerPoint content for the book used for the class. That book, as you can see on your screen, being Muroc C# 2015. In addition to doing these PowerPoint presentations, I've also been creating kind of a perpetual payroll program that I've been doing two ways. First, as a console application, and second, as a GUI app. But for now, I'm concentrating on the PowerPoints. I have so far completed chapters 1, 2, 3, 4, 5, 6, and 7, and I'm in the middle of chapter 8. So, we left off last time. We're on slide 40 of 68. We've talked a lot about arrays. Now, I didn't even do this before, but I'm going to do it anyway. It just kind of hit me right here. So let me make my font bigger here. Make it about 36 point. All right. When I first moved to Missouri, my wife was still living in Illinois. The reason I'm telling you that is because I got an apartment for a couple years. And imagine, the apartment I lived in actually was an 8-unit apartment. So if we have 8 units, all right, there's unit 1, 2, 3, 4, 5, 6, 7, 8. Okay, makes sense. And let's say that in unit 1, I lived there. So Scott was the last name. Unit 2 was Jones. Unit 3 was Smith. Unit 4, Green. Unit 5, White. Unit 6, Black. Unit 7, let's say Kelly. And Unit 8, Barnes. All right. And let's suppose, for lack of something better, that this apartment complex is located at 123 Main Street. Now, there's a pretty good chance if somebody sends me an USPS mail and they send it to Jeff Scott, 123 Main Street, let's say Wentzville, Missouri, 63367. I'll probably get it because the mail person will probably be smart enough to go and take something for Scott and put it into the right mail slot. Okay? Now, it would be better if they said Jeff Scott, apartment 1. What would happen if they said Jeff Scott, apartment 8? We don't know. They might deliver it to the right one, or they might deliver it to the wrong one. So why am I telling you this? Well, if you looked at this as 8 different units, okay, as opposed to looking at it as 1 unit with 8 compartments. So why am I telling you that? All right. Well, let's say that we created a string array and we called it families. Okay. And we said that it was equal to Scott. And let me just grab all these. It's going to be a little wide, but I'll fix it in a minute. Not going to put a lot of blank spaces in here. Just put a single space in. That should, hopefully we'll have enough room here. The reason that I'm going through this and taking the time to do this, all right, not to waste my time, not to waste your time, all right? Now, that's one way I could do it. I could also say string, bracket, bracket, families, equal, new, string, bracket, and put an 8 there. Why would I do that instead of this? Maybe it's a brand new apartment, and as people move in, I say string 0 equals Scott, string 1 equals Jones, string 2 equals Smith, string 3 equals Green, string 4 equals White, oops, string 5, I mean, you're getting the idea, I'm sure, equals Black, string 6 equals Kelly, string 7 equal Barnes. So what I would like you to understand is doing this and doing this aren't all that different, or this. But here we're looking at it as a single unit. In fact, that shouldn't be string there. Let me fix this. It should be families 0, families 1, families 2, families 3, families 4, families 5, families 6, and families 7. And typically, you don't even put a blank space in there. There. All right. So doing this, if I had all 8 families move in at once, would be a quick, down and dirty way of doing it. But if the families were moving in a month at a time or whatever, this would be another way of doing it. Now, I could have done this. I could have said string, family. In fact, let's just put it on the next line there. String, family, 1 equals Scott. String, family, 2 equals Jones. String, family, 3 equals Smith. String, family, 4 equals Green. String, family, 5 equals White. String, family, 6 equals Black. String, family, string, family, 7 equals Kelly. And string, family, 8 equals Barnes. Now, the reason I put all of this up there is to show you the correlation between an array element and just a regular variable. These are 8 different variables. This is one variable with 8 different components. It's much easier to handle in computerese something like this, where it's just one variable as opposed to something like this. I mean, imagine that this was a complex that had 50 different 8 apartment units, and they went from apartment 1 to apartment 400. This would be much simpler to do than this would. If you had 400 units, even with 8 like this, I might want to use a loop to to put this stuff in. And I've shown that in earlier examples. Now, what we're getting into next is kind of an array on steroids. See, when you create an array in C# is what's known as an early binded type of variable. What that means is when you create an array, you have to know the exact size of the array when you create it, and it can't change after you've created it. All right? And arrays can only hold the same, one or more of the same type of value in C#. So I can have an array of strings like I just showed you. I could have an array of integers that represented people's weights or people's heights. I could have an array of doubles which represented people's salaries, etc. A collection is a little stronger than an array. As it says here, both arrays and collections can store multiple elements. All right? Arrays are part of the C# language. Collections are classes in the .NET framework. So they expose a lot more methods that allow you to do things with collections that you cannot do with arrays. Notice this is maybe the biggest. Arrays are fixed in size. Collections are variable in size. So you're able to make collections bigger and smaller as needed. Here are some of the commonly used collection classes. I'm not going to read these. And we will be getting into these in more depth and breadth of coverage as we go on. All right. If you want to use collections, you have to add a new using statement to the top of your program using system.collections. The simplest type of collection to use is the array list. Array lists are not as popular as they used to be. Notice it says here that although they're very efficient for accessing things in a sequential order, A, B, C, D, 1, 2, 3, 4, etc., they can be inefficient when you want to insert elements into the middle of a list. So if I've got 500 elements, and I want to insert something in a new element 250 right about in the middle, I've got to go through the first 249 elements to get to my 250th element. The other ones that are in here, all right, are much better as far as being able to work with inserting elements, okay? So here's an example of an array list. You create a new array list called numbers. You don't even give it a size. You add different values to it. Now, this will work, this won't work. It'll compile, but as it says, it causes a runtime error. Why? Because array lists, all right, must hold values of the same type. Number, string. Well, that's going to break it. All right? So when you try to do that, it's going to break. All right? Now, they show here how you can do this and cast this, or try to cast this as a number. It probably will put a 0 in there. I don't know. It probably will give you 10 if you do this. Now, when you go in and you use other types of collections, as you start to see on this slide, it becomes more complex. Previously, we used an array list. Didn't look that bad. It's called numbers. We can tell it's an array list because, new array list. It's also an object because it uses the new operator. Now, look at this. When you use a list, which is much more common, all right, a list is much more common, you tell it what type is going into the list. So I'm going to have a list of integers that's called numbers. It's equal to a new list of integers, and notice paren here. we can put a size in there. We again add values to it, and we again can add. Again, it's expecting the values to be of the same type. What type? Type int. That's why we wouldn't want to put this in there. So we can have a list of strings, a list of decimals, etc. Here's a string with a capacity of 3. So it'll have element 0, element 1, and element 2. Typically what happens though is when you want to make the list bigger, you just add a new element and boom, it gets bigger. So some of the ways that you can work with this stuff, some of the common properties and methods of the list class are shown here. Again, they're treated like arrays and that the first element is element 0. Capacity, as it says, will get or set the number of elements by default the list can hold. Count is the number of current elements in the list. You can add elements in a list. You can clear everything from a list. And here's more. You can check to see if an element is in a list. You can insert elements into a list wherever you want. You can remove the first element that's in a list. You can remove any element at any index in a list. You can run a binary search, and I explained that to you in an earlier lecture. All right, on a list. You can sort a list. So if you're going to run a binary search on a list, you would sort it first, because you always want to run a binary search on a sorted list. All right, so notice we've said here there's 3 elements, right? 3. 1, 2, 3. Now we add another one. So the list automatically doubles in size. So it doubles to 6. Now we got 1, 2, 3, 4, 5, 6. We add another one. So it doubles again to 12. So once it gets filled up, it'll automatically double in size. You can retrieve values from lists, as is shown right here. You'll notice when you look at this second line that's right here. Notice it says equal new list decimal. This could be on the same line. They just put it on 2 lines. Doesn't look that different than when we set up an array before and we initialized it. The difference is we need new, because it's an object, list, and then the type of list. All right, let me double check my time here. All right, I'm at 18 minutes already. I know that I went a little long at the beginning explaining and kind of wrapping up arrays, but I'm going to stop right now, continue on again in the next lecture.